This video is for topic 7.13, pH and solubility. The objective for this topic is to identify the qualitative effect of changes in pH on the solubility of a salt. When an anion reacts to form a weak acid, the salt will become more soluble in acidic solution. So what we're going to look at here is an application of Le Chatelier's principle. So our example in this case is lead 2 sulfide. So lead 2 sulfide is a solid, and it is going to break up into its lead ion and its sulfide anion. So that anion can then react with water to form hydrogen sulfide with a -1 charge and hydroxide. So if we think about Le Chatelier's principle, if we add acid to this solution, so we have an equilibrium here. So if we add acid, that's going to react with the hydroxide ion to form water, which will then shift the equilibrium to the product side because we would have less hydroxide. So then to reform that hydroxide and reestablish the equilibrium, the sulfide would then continue to react with water to continue to make the HS -1 and the OH -1. As a result, we would need to dissolve more lead 2 sulfide in order to replenish that sulfide anion. So you can see this kind of in two steps here. So if we think about our PBS, our lead 2 sulfide, breaking apart into its ions, and then the anion specifically reacting with water to steal a hydrogen, then we're going to be left with our conjugate base, or our conjugate acid, and hydroxide. When you add acid, that acid is going to react with the hydroxide. It's going to it's going to force all of our equilibriums to shift to the product side. So if we react acid with hydroxide, the hydroxide then drops out and we have to replenish it. So to replenish the hydroxide, we need to react more sulfide ion with water to form our hydroxide, which means we need more sulfide ion. To get more sulfide ion, we need more lead 2 sulfide to react or to dissolve. So that's how we can use Le Chatelier's principle and our knowledge of acids and bases to look at how pH might affect the ability for something to dissolve.